kryptonite coming in there, 3 doors down. Take a look at what's going on today. We've got Pearson realized 23.3 rotations. This is going to be a little more challenging. 23.4 is going to be challenging as well. So here we go, taking a look at 23.3. We're going to start with key concept. Again, graph paper, hugely beneficial here. Be willing to spin the graph paper. Code word will be coming up here in just a little bit, or code phrase in this particular case. Here's what we got going on right here for this young lady who may have a cold today. Freezing in here.
A rotation is a rigid motion that turns a figure about a fixed point called the center of rotation. The angle of rotation is the number of degrees the figure rotates. A positive angle of rotation turns the figure counterclockwise. Suppose the origin is the center of rotation. You can rotate a figure 90 degrees, 180 degrees, 270 degrees, and 360 degrees about a center of rotation.
All right, now, taking a look at this. This is really important, okay? You are going to be rotating. If they tell you to rotate it 90 degrees, 180 degrees, 270 degrees, you're going to be rotating it counterclockwise. So you're going to have to recall that this is quadrant number 1 right here. This is quadrant number 2, quadrant number 3, and quadrant number 4. Also would benefit you if you remember that quadrant number 1 was positive in terms of their XY values. Quadrant 2 was what? Negative, positive. Quadrant number 3 would be your negative, and quadrant number 4 would be your what? Positive, negative. It'd be very huge if you could recall that or write that down somewhere. Also remember, if you were to rotate it 270 degrees, you could make the argument that's just like rotating it negative 90 degrees. Now, obviously, Pearson's not going to count that, but it may lead to less steps for you in some of these particular problems. We take a look now at my next piece of the puzzle. We'll just go ahead and roll to part number 1. So if we take a look at part number 1, again, graph paper is going to be beneficial here. We have to identify which one of these is the rotation. And again, this being multiple choice potentially, your best case scenario is maybe we identify the ones that aren't rotations. So if I take a look, for example, at the first one, it's a possibility that could be rotation. Remember, we've already talked about 2 of these pieces. We've talked about translations. And if you take a look at number 3 here, this looks like it's a translation because all we're doing is sliding everything upward. And it looks like we're sliding everything upward, what? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So all this is a translation. If I take a look at the second one, so obviously the third one's not it. If I take a look at the second one represents a flip or a reflection. If you take a look at that, we're flipping it or reflecting it across the x-axis. You can see that this is 1 away from this, B and B prime are 1 away from each other. C and C prime are 2 away from each other on opposite sides of the mirror, and A prime are 3 away from each other on the opposite sides of the mirror. So if I took a look at this, we could basically say that this one then must be our rotation. This would be your answer. If we take this rotation, we're going to rotate it around the origin likely. And when I do this, pay attention. Look how far this is away from this. When I rotate it 90 degrees, it's going to rotate, it's going to be 2 away from the y-axis. And again, physically spinning your paper here, I think would be a very good idea if you freed yourself up and just completely spun the paper here. We could also take a look at this. Since this is 1 away from the x-axis, it's going to be 1 away from the y-axis. And since this is, what, 4 away in essence from the x-axis, it's going to be 4 away from the x-axis. All right, that's just one thing that you can look at in terms of determining these particular situations. All right, so again, this is going to be a little tougher. I got to think this is going to be a little bit tougher than what we've been doing. You probably found those first 2 assignments, relatively simple. All right, let's move on to my next slide on part 1. If I take a look at this next slide on part 1, which graph shows a rotation around the origin. And again, you're getting lucky here because it looks like everything I saw was, for the most part, around the origin. We could obviously make this much more difficult if we rotate it around a specific point. So make sure you understand that. This could get a lot more difficult. If I take a look at this one, once again, I would identify this one. This appears to be a translation. All we're doing is sliding it downward. This one appears to be, if I take a look at this versus this, looks like it's again a reflection. This is what, 3 apart, 3 apart, 4 apart, 4 apart on opposite sides, assuming that my line of reflection is my x-axis, it appears. And so that appears as though this one is going to be your lineup, or your one with which is regarded as a rotation. And this will be a rotation of 90 degrees. How do I know that? Once again, if I take a look at this, point F, if I take a look at point F, it is 1 away from this, and so it's going to be 1 away from this. If I take a look at D, D is 2 away from the y-axis. If I rotate it 90 degrees, it's going to be 2 away from the x-axis. E is 4 away from the y-axis, and you can see here it's going to be 4 away from the x-axis. Again, some clues coming up down the road that I'm going to, I think, construct myself in order to help you understand the whole rotation thing. All right, moving on then to part 2. Part 2, again, in this situation, I'm going to step it up a little bit. All right, let's watch this little video clip from this cat.
You can use a protractor to find an angle of rotation. Suppose you have a point P. You rotate point P about a center of rotation O. You can find the angle of rotation with a protractor. The angle of rotation is 135 degrees.
All right, so if I take a look at that next piece, they're going to give us one just like that. All right, so what's the angle of rotation in this particular situation? Obviously, we're going black to blue. All right, so my angle of rotation, one of the things that I could do is it appears as though my angle of rotation is the origin, okay, as most of these, if not all these problems are. And so one of the things that they've suggested to do is that you basically draw a line, and again, you could think about doing it this way. Hey, I'm going up 1 over 2, up 1 over 2 from the origin. That line then goes just like that. All right, over here, I'm going to the left 1, up 2, left 1, up 2. So again, right there would be my line in this particular situation. It's not very good, but, and if I pull my protractor over here, then what I could see is that if I rotate that baby up there like so, that my angle of rotation, again, you want to get this lined up properly. At this point, it might not have let me to do that, but basically your angle of rotation here is going to be 90 degrees. And again, they're going to give you cupcake numbers. They're not going to make it, 93 or 94 in this particular situation. So that's how you would perform that scenario. That would be helpful. Moving on to part 3. Angle of rotation about the origin that maps this. Again, one of the things to pay attention to here is, here's basically your original, okay? So if I looked at line segment OK, that's your original. Take a look at what's happening here. Line segment OK is going to go completely around, and it's going to basically create this whole straight line. So if it creates that straight line, then your rotation would have to be 180 degrees. So your choices there, they're going to give you those 4, which are going to be common, and then the correct answer is going to be 180 degrees. Okay? Now, again, something that would help you out is if you completely understand, hey, here's point J, and point J, if I'm going to rotate it 90 degrees, then point J would have to end up in quadrant number, what is this, 3? Yeah. If I were to rotate it 180 degrees, then J would have to end up in quadrant number 4. If I rotated it 270 degrees, then point J would have to end up in quadrant number 1. So those are some things that you could take into account to kind of ease your pain here as you go through this material. All right. Okay, let's sneak in our code phrase for today real quick. Here we go, ready? Code phrase for today is underdog is here. Ask your parents who underdog is. Underdog is here. That's the code phrase you need to be typing in for 22.3. Back to business with slide number 4. Come on, slide number 4. We want to map ABC so that, we want to map ABC so it's image A prime, B prime, C prime, where A equals A prime, B equals B prime, and C equals C prime. What's the angle of rotation? So in other words, we want to get it back to its original state. And if we want to get it back to its original state, we'd have to rotate it 360 degrees or a multiple of 360 degrees. So you could say 360 would work. You could say 720. Add another 360 onto here. We're looking at 1080, right? Anything that follows that pattern is going to get you right back to the original situation, all right? Slide number, or should I say part number 3 coming at you. All right, so here we go on part number 3. This is just going to basically give you some information here, not really anything to do on this particular slide, I don't think. All right, so again, they're talking about arrow notation. All right, arrow notation, if we move this image after a rotation. Now again, a couple things I want you to be a little bit aware of. Take a look at C, all right? Take a look at C, for example. We're going to rotate this thing. It says 270 degrees, all right? 270 degrees. If I rotate it 270 degrees, and this thing's starting in quadrant number 2, then you have to understand, hey, it's going to end up 90 degrees would be quadrant number 3. Quadrant number 4 would be a 180. So C is going to have to end up in quadrant number 1. And if you know that, you're going to be able to pick out these images a lot quicker. The other thing I want you to pay attention to is on a 270 degree rotation, look at what you started with on C. You started with -1, comma 4, and look at where you ended up on a 270 degree rotation. You ended up at 4, comma 1. Right? So again, knowing that it's going to end up in quadrant number 1 is going to help you, because you'd have to know, if this was multiple choice, that you're going to have to end up with a positive X value and a positive Y value. All right? Moving on to slide 2. So on slide 2, what they want you to do, they want you to take a peek at this. We have a rectangle, 1, comma 2, 1, comma 0, 5, comma 0, and 5, comma 2 are our points. They want you to drag that rectangle to show you the image of ABCD after a 90 degree rotation. So the first thing that you guys should be thinking about is, dude, if I go 90 degree of rotation, I'm currently starting in quadrant 1. That means I'm going to end up in quadrant number 2 on a 90 degree rotation. So if I take this figure and I rotate it over, it's going to end up right there. Okay, now, one of the things I want you to pay attention to, and this is where we're going to take some time, so this is going to eat up some time here. If I look at A on a 90 degree rotation, A is 1, comma 2 is my starting point. Look at where I'm at right now. A is going to end up being right here. This is A prime. All right, so A prime on a 90 degree rotation ends up at what? -2, comma 1. Let's just take a look at another point. Let's go ahead and take a look at B. B started off as what? Right there would be 1, comma 0. Look at where B ended up. This is going to be B prime then, right here. And so B prime is going to end up at 0, comma 1. Okay? Now, what if I did this is on a 90 degree rotation. Okay? What if I did a 180 degree rotation? If I did a 180 degree rotation, let's take a look at those same exact dudes. Remember, I had A at 1, comma 2. I had B at 1, comma 0. Look at where this thing ends up. I'm going to go ahead and rotate this figure again quickly just to show you where it's going to end up. it's going to end up right there on a 180-degree rotation. So my 180-degree rotation, once again, where are we at here? This would be B, in essence, in this case, B double prime. And this would be A double prime right here. So A double prime, which basically means you did two things, is going to end up at what? -1, -2. -1, -2. And B double prime is going to end up at what? -1, 0. Right? So you should be able to potentially see some relationships between these numbers. We take a look at the last one, and on the last one, we get a situation that's going to look like that if I did a 270-degree rotation. Okay? They want you to use arrow notation on this. I'm just trying to give you the full picture here of some things that would help you when we get to those more difficult problems. And so if we wanted the situation with angles, here's basically what you would have ended up with. They show you the rotation just like I did, okay? And they show you that with angle notation, or that 1, 2 goes to -2, 1, which I believe I stated. 1, 0 goes to 0, 1. 5, 0 goes to 0, 5. And 5, 2 goes to -2, 5. All right? Move on to our last slide here. Point P is coordinates 3, 0. If I rotate it about the origin, what are the coordinates of P prime? These were my choices, very common choices. Once again, if you were to draw this bad boy out, and we said, hey, P is 3, 0. So 3, 0, I'm going to switch some colors here. 3, 0 is going to be located right there. And so if we rotate that 270 degrees, that dude's going to, this would be 90. This is going to be 180. And then 270 is going to be right about here. All right? So what point is that? Obviously, I'm on the y-axis. And if I'm on the y-axis, my final answer should be 0, and I'm 3 away from the origin on the downside, so my answer should be 0, -3, and in fact, that's the case. All right? Hopefully you got something out of that. Good luck with that. If you need some help, please feel free to email me with some discussion points. Please be specific in those discussion points. Have a great day.